Hello everyone. Today I am going to explain how to derive the expression for total strain when a body is subjected to three mutually perpendicular stresses in three directions. So this is a body A, B, C, D, E, F and G. It is a rectangular body whose length is BC. I have taken it as X. Height CD, I have taken it as Y, and the width CF, I have taken it as Z. These are the three directions, X, Y, and Z directions. Sigma X is the tensile stress acting in X direction. Sigma X, tensile stress acting in X direction, that is in the direction of length, because I have taken BC as the length X. Now sigma Y again, I have taken it as tensile stress acting along Y direction, that is in the direction of the height CD. And the third one is sigma Z acting along in Z direction, that is in the direction of width CF. So these are the three stresses acting in three mutually perpendicular axes X, Y, and Z. Now what we have to find? We have to find out what is the total strain acting along the x-axis and what is the total strain acting along the y-axis and what is the total strain in z direction because of these three stresses. That we will find out. So in the first, I have taken only sigma x acting along x direction. The body is same ABCD and sigma x is the tensile stress acting along x direction. Now, because of this stress, length of the body, that is the BC, will be under tension. That means the length will increase. And other two dimensions, that is the height CD and the width CF, it will be under compression, and because of this, these two length, this is CD and CF, will be decreased. So we can say along the line BC, that is BC will be under linear strain, but CD and CF will be under lateral strain. Means BC length will increase, but CD and CF will decrease because of this sigma x stress applied on the body. So now, if E is the Young's modulus of elasticity, then we know from the Hooke's law, stress is equal to modulus of elasticity multiplied by strain. So we can find out the linear strain in x direction. In the x direction, the linear stress is sigma x and the modulus of elasticity is E. So I can find out the linear strain along x-axis or x direction is equal to linear stress, it is given sigma x, and the Young's modulus or modulus of elasticity divided by E. So sigma x by E is the linear stress along x direction. Then also we know what is Poisson ratio. Poisson ratio is denoted by mu, and it is the ratio of lateral strain by linear strain. Poisson ratio is defined as the ratio of lateral strain to the linear strain. Now, along the length BC, there is a linear strain, but in the direction of CD and CF, there will be lateral strain. So we have to find out lateral strain in y direction and z direction. So see, lateral strain in y direction. In y direction, what will be the lateral strain is equal to mu multiplied by linear strain. So mu is here, a linear strain is sigma x by E. Now I put it here negative, because negative why? Because decreasing. CF and CD lateral dimension, it is compressed. Both the lengths CD and CF are compressed. So I have taken it as a negative minus mu sigma x by E. Similarly, lateral strain in z direction will be same minus mu sigma x by E. So I got, because of the sigma x stress along the x direction, the linear strain in x direction is equal to sigma x by E, and lateral strain in y direction is minus mu sigma x by E. Similarly, in lateral strain in z direction is minus sigma x by mu. Okay, now I am considering the stresses along y direction, that is sigma y acting in y direction, and this stress is also tensile in nature. So here, because of the sigma y stress, which dimension will increase? Y direction, that is CD will increase, but BC and CF will be decreased. So that means along y direction, that is along CD, we will get linear strain, and along BC, that is along x direction, and along CF, that is along z direction, we will receive lateral strain. So linear strain in y direction, we have the linear stress. What is linear stress here? Sigma y, sigma y. And if I divide this stress divided by E, so I will get the linear strain in y direction. Then what is the lateral strain? Lateral strain will be there in x direction and z direction. So in x direction, it is minus mu multiplied by sigma y by E. In z direction also, minus mu sigma y by E. That means now I got, because of the sigma y stress, the linear strain in x direction is sigma y by E. The lateral strain in x direction is minus mu sigma y by E. Lateral strain in z direction is also minus sigma y by E. Okay, now next is z direction. Now the stress is along the z direction. So because of the z direction stress, CF will be under tension, it will increase, but BC and CD, it will be under compression, it will decrease. So that means along CF, that is along Z direction, we will receive linear strain, but along BC, that is along X direction, and along CD, that is along Y direction, we will receive lateral strain. So linear strain in Z direction, is linear stress in Z direction is sigma Z divided by the modulus of elasticity. So I got sigma Z by E is the linear strain in Z direction. Linear lateral strain in X direction, because in X direction there will be lateral strain, it is minus mu sigma Z by E. Similarly in Y direction, it is minus mu sigma Z by E, mu multiplied by linear strain, negative because of compression, Okay, now it was our problem, three stresses acting in three directions, these are the axes. Now see, this is the table. Because of the sigma stress, linear strain in x direction, it was sigma x by E. Strain in y direction, it was minus mu sigma x by E. Strain in z direction, it was minus mu sigma x by E. Similarly, because of the stress sigma y, linear strain in y direction, it is sigma y by E. And in the other two directions, there will be lateral strain minus mu sigma y by E, minus mu sigma y by E. Similarly, z direction, sigma z. For the sigma z, in z direction, there will be linear strain sigma z by E. And in other two dimensions, there will be lateral strain, that is minus mu sigma z by E. So now, if I add this term, I'll get the total strain in x direction. So total strain in x direction is Ex, sigma x by E positive, minus mu sigma y by E, minus mu sigma z by E. Then if I add this term, these three terms, I'll get the total strain in y direction. So in y direction, sigma y by e is the positive, it is linear. Rest is minus mu sigma x by e minus mu sigma z by e. And the last case, sigma z for Ez, that is total strain in z direction. So total strain in z direction, I have to add these three terms. In z direction, sigma z by e is the linear strain. In the rest two directions, it will be lateral strain, so it is minus mu sigma x by e minus mu sigma y by e. So these are the total strain along x, along y, and along z direction. So this is the main expression for the strain in different directions because of the three stresses acting in three different directions mutually perpendicularly. Now, with this expression, we can also find out the volumetric strain produced in the body. Now, how? So the expression, the problem is same. Three stresses sigma x, sigma y, and sigma z are acting in three mutually perpendicular directions. Then what will be the volumetric strain produced in the body, developed in the body? See, these are the expression for Ex, Ey, Ez. That is the total strain along x direction, total strain along y direction, total strain along z direction that we have already derived. Now, to find the volumetric strain, what is volumetric strain? Volumetric strain is change in volume by original volume. Then what is the original volume? Original volume is because the length was x, height was y, width was z. So the volume is x, y, z. So B is equal to x, y, z. Take the logarithm on both sides. Then ln b is equal to ln x plus ln y plus ln z. Then if I differentiate this equation, above equation, I'll get dB upon b is equal to dx upon x is equal to plus dy upon y plus dz upon z. Now what is dB upon b? dB upon b is the volumetric strain. What is dx upon x? X is your original length and dx is change in length. So change in length by original length is the strain along x direction, that is your Ex. Similarly, dy upon y, change in length in y direction divided by y, that is your Ey, and dz upon z, change in length in z direction divided by the original length z, change in length in z direction divided by original length, so it is Ez. So that means I am getting Eb is equal to Ex plus Ey plus Ez. And we have these equations, Ex, Ey, Ez, already we have derived it. So if I put Ex plus Ey plus Ez, you see this expression, sigma x by e, sigma y by e, sigma z by e. So I am adding these three terms, Ex plus Ey plus Ez. So one will be sigma x by e plus sigma y by e plus sigma z by e. Then you see, this is minus sigma y by me. And again here it is minus sigma y by me. That is 2 minus sigma y by me. Similarly, this is minus mu sigma z by e. This is again minus mu sigma z by e. Here it is sigma x by e minus mu sigma x by e. Here it is minus mu sigma x by e. So two terms are there. So sigma x by e plus sigma y by e plus sigma z by e minus 2 times of mu into sigma x by e plus sigma y by e plus sigma z by e. So here I have put sigma x by e plus sigma y by e plus sigma z by e minus 2 times of mu into sigma x by e plus sigma y by e plus sigma z by e. Then take common sigma x by e plus sigma y by e plus sigma z by e. If I take common, then I am getting volumetric strain is equal to sigma x by e plus sigma y by e plus sigma z by e into 1 minus 2 mu. So this is the expression for volumetric strain. So with this I have completed this topic. Now for any queries or discussion, you can mail at this nurulhasanlashkar.me@iccollege.com, or you can also send mail nurulhasan2@gmail.com. I always welcome a suggestion. Thank you.